All right, this is section 8.2, families and periods of the periodic table. Note as we go through here, there's going to be a couple items that I'm going to want you to put on the outline very specifically, so make sure that you listen for those. There'll be a couple things that I want you to do that aren't just fill in the blanks. All right, here's the objectives. First of all, in this lesson, section 8.2, we want to be able to identify the groups that are on the periodic table and talk about valence electrons for each one of those. And then talk about the relationship between behavior of the families and their configurations. And then we're going to get into periods, and last be similarities among elements in the same period in the periodic table. Okay, so we've talked a little bit about Mendeleev before, but he put the elements in positions based on their chemical behaviors. In other words, kind of like what compounds did they form. So if we were talking about like group 1A, lithium, sodium, potassium, and so on, they tend to form compounds with chlorine in a 1-to-1 ratio. And all of them tend to do that, form those similar compounds. They're all very reactive. So he said he took those and grouped them together based on their properties. Together, those vertical columns we call families. Sometimes they're also called groups. Okay, so groups or families, either one of those, we're talking about the same thing. We're talking about the ones that go up and down, the vertical ones. On the periodic table that we have today, the modern periodic table, there are a couple different versions as far as some of the conventions, some of the numbering that we have. There's the older convention where things were labeled with the numbers and then A's and B's. And if you can see this, it's kind of a little blurry, but like this would have been 1A, group 2, 2A, and then we would skip all these. These are all B's. If you can't see that, these guys right in here, those are B's. Then this would be 3A through 8A is what those are. And this is the older convention. Then the newer one is that you just number everything. Hey, 1, 2, 3, 4, all the way across to 18. The newer one is simple, obviously, 1 through 18, but it doesn't tell us as much. It's not as useful for us. So we'll actually usually use the older convention. Kind of gives us a little bit more information about things, especially when we're working on forming compounds and so on. It'd be better. Okay, so the newer one's 1 through 18. All right, so let's talk about these different groups. Take a look at the configurations here. And so notice that for lithium, it's 1s2, 2s1. Lithium ends in 2s1. If we talk about sodium, 1s2, 2s2, 2p6, 3s1. And so on. The potassium ends in 4s1. And rubidium in 5s1. And this is the key thing. All of these have one electron in that s sublevel, one valence electron. And this is a relatively unstable arrangement. So these are very reactive metals because of that. So they're always trying to get rid of that electron. They're trying to share it or give it away to another atom because it makes them more stable. And it gives them very similar properties. They're all really reactive. If you take any of these things and put them in water, they will react violently. Take sodium, put it in water, and it'll start to burn. You take things like cesium and put it in water, and it'll explode. The group 2A elements are known as the alkaline earth elements, and you can see if you look at their configurations that they have a 2S or an S2 in all of those. So if you look at, the shortcuts are always good ones because they just show you the valence electrons, and you can see 2s2, 3s2, 4s2. So all of these have 2 valence electrons. That puts them in 2A. Okay, so all of the S, keep track of the fact that all the S and P's, these are our group A elements. Okay. Now we filled up the S, so if you keep on going now, you start to see that we're starting to fill the P. So here's group 3A, 2s2, 2p1. Group 3A doesn't really have a special name. In the new convention, it's group 13, but no special name that we usually give to it. But notice that all of these have that S2P1. You know, even though they're filling some D's, notice that that D level is behind. It's a 3D level. And this is why we rearrange them. If we rearrange them, that doesn't look like it's in the middle of it. You know, so rearranging kind of actually makes it look a lot easier. You know, even when we get down here and we've got some F's and some D's in there, you still finishing with 6s2, 6p1. 3 valence electrons, group 3a. And our group 4, you know, 2s2, 2p2. All of these are going to end in s2p2. S2P2. Once again, these don't have any special name, just group 14 or group 4A, and we won't refer to them as these numbers ever. I'll always kind of talk about them as the group A, or a lot of times they're called the representative elements. The group A elements are, and the reason that they're called that is because they kind of give you a good representation of all kinds of things, all the way from metals to nonmetals, and you know all the variety that you're going to see. All right, group 5, same thing. S2P3, S2P3, S2P3. Now, on the group 6, what I'd like you to do on your outline, go ahead and write in. Let's just do the first 3. I don't think we need to do more than that. But stop the video, and I want you to write in the configuration. So do the 1s2, 2s2, all that good stuff for those 3, and just put it on the side of your outline. So stop the video and do that right now. But you can see group 6 is the group 16 overall. Once again, there's no real name. It's oxygen's group. You know, it starts with oxygen, sulfur, selenium, so on. You probably should have a pretty good idea of what these are all going to end in. You may do the shortcut method if you want. Okay, our last 2 groups, when we're talking about these representative ones, are groups 7A and 8A. So we're talking about group 7A are halogens, group 8A are the noble gases. Now make sure that you know we've named basically 4 main names, or 4 new names, whatever. 1A, those were the alkali metals. Group 2A, alkaline earth. Group 7A, the halogens. And group 8A, the noble gases. Make sure you know those names. You'll be expected to know those on a test. And then, so those were the A's. That's all these and these. Then the ones in the middle here, these are often called the transition elements. And in these, we're starting to fill the D sublevel. So if we're going with the old convention, they're often called the group B elements, and we don't refer to them a lot. I mean, I'm not going to use numbers for them or anything. Most of the time when I talk about them, I'm going to call them the transition elements. But you can see that they do have down here, there's the B's in there. In the new convention, it's just numbers 3 through 12. But make sure you know them as the transition elements. And what's happening in these is we're starting to fill the D sublevel. So, you know, they're kind of showing you here, potassium would have filled the 4s1. Calcium, you know, 4s2. And now we're going back, scandium is now filling, you know, 3d1. You know, if we continue on the chart, you know, titanium, it's going to fill here, you know, and so on. So we're starting to fill these D sublevel here. Those are the transition metals. Notice that the D level is always behind. You will always be filling one behind when you're filling Ds. Notice we started on the 4. We were in the 4s, but we're filling 3 Ds. Ds are always one behind your 4 or your S level. One behind the S. And then the bottom of the chart, if you look at the bottom of the chart, we have the what are known as the lanthanides, and these are atomic numbers 57 to 70, and those we're filling the F sublevel. Okay. The other ones, and these kind of, they each row gets its own name. These are known as the actinides, and if you notice, they're named after the first element in those. And these are now filling this, the 5Fs. These guys are filling these guys in here. Okay, and those are elements 89 to 102. These are the Fs, and you'll notice that, we've filled, if we go back to the other one, we've filled a 6S, then we're filling a 4F, and the actinides, we're actually we filled the 7S, and then we've gone to the 5F. So you'll notice that Fs are always 2 behind what you're filling in your S's. Okay? So we said D's were always 1 behind, F's are always 2 behind. So if you look at the periodic table, look at the whole thing, you can see how this was built. And it's what the most interesting thing about this is that Mendeleev was putting this together without knowing about electrons, without knowing about sublevels and all those things. And he put them together based on properties, and it ends up being, well, we understand now why it's together that way, and it has to do with the electrons and the sublevels and so on. So all of these guys right here, these are known as the S block because that's what you're filling. You're filling the S sublevel. Over here, these are known as the P block because you're filling in the P sublevel. In the middle, these transition ones, these are the D block. You're filling the D sublevel. And down here, the lanthanides and the actinides, sometimes known as the inner transition metals. Okay, these guys are filling the F block. So be aware of that. You can always just look at the periodic table now and figure out, oh, well, we're going to be filling a D. That's where I should be ending. And, one of the things that you should notice, if I'm here, that I'm filling a D1. If I'm here, I'm filling a D2, D3, and so on. That's how it works. Here's a P1. Here's a P2. Here's a P3. Here's a P4, and so on. That's how it is. Now, let's talk about it. We've been talking about the groups or families. Let's talk about the periods. And notice that we're just doing the representative elements. We're just taking those 1A through 8A as we go across here, talking about the periods. And, you'll see on the periodic table, there are 7 periods. And, this particular one is not full yet. We haven't found the elements all the way across, although, and as far as found, they were actually making them. They're not finding them. They're creating them in the lab. And I believe the latest one was 115. They had previously created 116, so I think that's how far we are as of now. Okay. So let's take a look at these, and what I want you to do on your sheet, instead of writing in, the word period, don't put that in there. I want you to put the name of the group, and we've talked about this, so I want you to tell me, for these guys right here, the ones we're looking at, okay, I want you to put in the name of that group in that blank. So write in what the name of that group is. And notice here, this is what they're trying to show you. Okay, 2S, that's this one. 3S, that's this one. 4S, that's this one. Notice that 4S is in row 4, 3S is in row 3, 2S in row 2. And so I think what they're trying to point out here, oops, wrong one, is that last level, the outer level, that tells you what row in the periodic table you should be in. So you should be able to look at an element like rubidium, and you say, oh look, it's in row 5. We know it's in group 1A, therefore it should be a 5S1. Should be able to do that. Okay? Or we could say lithium, hey, that's in row 2, so it must be a 2S1. Okay, once again, in group 2 in these now, in the blank on your outline, put in the group name that we've talked about for those. Put in the group name. Don't just write in the word period, put in the group name. And once again, take a look. Here's our 2s2. We're looking at that one. Here's our 3s2. We're looking at that one. So you should be able to go down here and say, hey, barium. All right, I'm looking at barium. It's row 6. It's in group 2. Ah, that's a 6s2 because I know those are my S blocks. I'm good at that. I can figure that out. If we move across to the other side now remember, now we're taking out all those in the middle here. But now we're looking at these guys right here, okay? And they're always going to be some kind of S2, P1. So if we're looking at boron, it's 2s2, 2p1. Aluminum, 3s2, 3p1. Gallium, 4s2, 4p1. But notice that we've got some D's in there now. Because once you get to the 4th level, you've got some D's filling behind you. You've filled your D sublevel before you got to the P's there. But you should still be able to tell me the valence electrons. And really, those are the important ones. So you should be able to look at indium, for instance, and say, hey, it's in row 5. It's one of those 3A ones, so I know it's going to be some kind of S2P1. You should be able to say, oh, it's a 5s2, 5p1. So at this point, what I want you to be able to do is look at the periodic table and tell me at least the outer configuration of these 1A through 8A elements. Once again, let's move across. We're over at the halogens now. Okay, so we're talking about these guys. Notice a 2s2, 2p5, 3s2, 3p5. When we get to row 4, remember we're going to have some D's in there. But if we rearrange these, and this is why we rearrange, we don't have to worry about it. You don't see that. So when you rearrange, you just know, hey, the outer level, and that's what we're talking about, is 4s2, 4p5. So I said, hey, give me the outer level for iodine. You'd say, oh, all right, it's a halogen. It's in group 7. I need 7 of them, so it's 5s2, 5p5. Okay? Now, you should be able to do that for every element in this group, in this representative elements. The first row sometimes is considered to be a little bit special, mostly because they're not filling a P sublevel. There's no P in level 1, and so it's a little bit different. Hydrogen is listed on these sides over here, but it's not like those in that it's not a metal. You know, all of those are metals. Hydrogen's not, but you'll notice that it still gets listed on this side. Although if you look at most periodic tables, there's usually a gap in there, so you kind of understand that it is a little bit different. So hydrogen's not a metal, but it acts in similar ways that these do. It will still form a lot of compounds in the same thing. So if we're talking about compounds formed with chlorine, you know, you'll get one hydrogen and chlorine. You'll get one lithium and chlorine. You'll get one sodium and chlorine. They still tend to have similar properties to that. Helium, unlike the other noble gases, helium does not have a P sublevel. All the other ones are S2, P6. Helium, just S2. But that's a full sublevel, or full level for that matter. And so it's very stable, and it doesn't want to react. So all of these noble gases, that full levels, when you get those S2, P6s, very stable. They don't react. In fact, that's why the noble gases weren't found for a long time, because they didn't form compounds. Most elements were separated from the compounds that they formed, and that's where they found them, they discovered them. But the noble gases don't form element or compounds, so they didn't do that. They couldn't find them. So for a long time, there wasn't anything listed. All right, that's it. Unfortunately, I forgot to put in a cute little joke here at the end. So this is my last slide, and that would be the end of it.